This is where we left off in our previous video. We looked at the rectangular form and the polar form of the complex numbers. Alright, now going to talk about this further on, but let us erase parts of the board. I don't want to erase the rectangular and polar form box. We want to keep those, or let's rewrite them over here now. So a plus bi, so z equal a plus bi, that's the rectangular form, and z is equal to r cos theta plus I r sine theta is the polar form of the complex number. Remember, the polar form contains the angles. Alright? Now, let us look at what would happen if we multiply two complex numbers in polar form. Alright, I'm not going to type it. I'm not going to write it. I'm going to type this thing instead. So let's bring these down a bit and add it to what we have here. So we're going to look at multiplication multiplication in polar form. Alright, multiplication in polar form. We want to multiply two complex numbers that are in polar form. Alright, so let us say we have two complex numbers. We call them z1 and z2. So we have z1 equal r1 cos theta plus, say, theta 1 plus I1 r1 sine theta 1. So we label them as 1. No, the I wouldn't be labeled. I is just the direction that we have the y-axis. Alright. So z2. So we have z2 equal r2 cos theta 2 plus I r2 sine theta 2, right? So we want to find z1, z2. So we have r1 cos theta 1 plus I r1 sine theta 1. And we're multiplying it by r2 cos theta 2 plus I r2 sine theta 2. Theta 2. Alright. So, multiply them out. What are we going to get? Z1, Z2 is equal to, so R1, R that times that gives us R1 cos theta 1, R2 cos theta 2. You see that? Then R1 cos theta 1 by I R2 sin theta 2. So it's plus R1 cos theta 1 times R2 sin theta 2. Let's put the I in front here. In fact, I don't want to just mix up the I. with everything else, you know. Right? Alright, let's put it there. I want to make sure we see the I clearly. Alright? What do I do? Put the I here. I in red. So we have the I there. We want to see it separate from the other numbers. Now, then what we have here, multiply these two. What do we get? We're going to get I. So we say plus I, and then we would have R1 sine theta 1, which is this here, see that? Times this R2 cos theta 2, and then multiply these two now. So what we get is plus I multiply I. So we have I squared, right? I squared, and then we have R1 sine theta 1, R2 sine theta 2. See that? So we have, what we have is R1 cos theta 1 times R2 cos theta 2 plus R1 cos theta 1 times I R2 sine theta 2. Then I R1 sine theta 1 times R2 cos theta 2, and then we have I R1 sine theta 1 times I R2 sine theta 2, but the I multiplies I, so we square the I. Alright, so let's continue. Z1, Z2 equals, so we have R1 cos theta 1, R2 cos theta 2, then we have here plus, here now we can put the I outside a bracket and factor out these things. R1 cos theta 1 times R2 sine theta 2 plus R1 sine theta 1 times R2 cos theta 2. See that? Then the I square becomes negative, so we say minus R1 sine theta 1 R2 sine theta 2. See that? After that now, we say what is Z1, Z2, right? It is equal to, now, what we have is, let's put R1 and R2 together now. R1, R2, cos theta 1, cos theta 2. What do we have out here? Minus R1, R2. So we minus R1, R2, sine theta 1, sine theta 2. So sine theta 1, sine theta 2. See that? Now, after all this, we say plus I. And then in the bracket R1, R2, R1, R2, Let's put the sine first. Sine. Alright, let's continue as it is, because we can put the theta one in order, right, in the same order. So what we have is R1, R2, cos theta 1, let's put cos theta 1 first, sine theta 2, alright. Then plus R1, R2, sine theta 1, cos theta 2. So we have sine theta 1, cos theta 2. Alright, let's continue playing around with this. What do we have here? Z1, Z2 equal. You know what? This R1, R2 business, you know. We can factorize, you know. We can take out all the R1, R2s. Because guess what? So we have R1, R2 times something minus R1, R2 times something. And then plus R1, R2 times something. So we can factor out all the R1, R2s. You see that? So we can say R1, R2, open bracket. So we have cos theta 1, cos theta 2. See that? Minus sine theta 1, sine theta 2. Right? Then that will be the real part. We factor out the R1, R2 here. So we have plus I, and then what we have after this is cos theta 1 sine theta 2 plus sine theta 1 cos theta 2, the imaginary part. So that's what we have there. See that? So here now you have a certain what is called compound angle trigonometric identity. If you look that up, you can rewrite this more conveniently. What you would have is R1, R2. Now, it will show that cos angle minus sine angle is going to be cos of both angles added, the sum of both angles, theta 1 plus theta 2, right? It's generally form cos A, cos B minus sine A, sine B is cos A plus B. But instead of A and B, we're using theta 1 and theta 2 plus I. Now, you see, there's another compound angle identity which you can look up, right? And it says sine A cos B plus cos A sine B is equal to sine A plus B. In this case, what we can say is sine, let's not keep repeating the theta for this part. Here, sine 2 cos 1 plus cos 2 sine 1 would be sine of 2 plus 1. If you look up that compound angle identity, it would say sine A cos B plus cos A sine B equal sine A plus B. So in this case, we say that cos with sine theta 2 cos theta 1 plus cos theta 2 sine theta 1 is equal to sine of theta 1 plus theta 2. So that is what we would have in this case. So here, this is the result of multiplying two complex numbers. So what we have is the product of the complex numbers, and then we have the sum of the angles. All right, so there we go. Z1, Z2 equal the product, I mean not the product of the complex numbers, what did I say before? Is the product of the magnitude of the complex numbers, right? Or the product of the modulus of the complex numbers, and then the cosine and sine will apply to the sum of the angles. Alright, so that's it for now. See you in the next video.